Yeah, go ahead.
Hello.
There you go. That's it. All right, so I'm going to start with point 0, 1. We're going to reflect over the x-axis. I'm going to move 1 and up 4. I'm going to take point -1, 3. I'm going to reflect it over the x-axis. Move 1. So the domain is going to be -infinity to infinity. The range is -infinity to 4. The y-intercept is 0, 1. Y equals 4. Okay, for the second one, the base is e to the x. So the points are 0, 1, and 1, and 2.7. I'm going to get a vertical compression of 2/3. So that's times y. I'm going to have a horizontal compression of 1/2, which is times x. So the down 5 is going to move the asymptote down 5. 1, 2, 3, 4, 5. I'm going to start with point 0, 1. So a vertical compression of 2/3 will move that here. The horizontal, it's 0, so it doesn't move. So I'm going to move 1 this way and down 5. 1, 2, 3, 4, 5. So the 1 and 2.7 is here. So a vertical compression of 2/3. So if you take 2.7 times 2/3, it's going to move here. The horizontal compression moves it back, and we move over 1 and down 5. So I get a domain of -infinity to infinity, a range from where the asymptote is. It's -5 to infinity. We don't have an exact y-intercept. It's increasing from -infinity to infinity. As x goes to infinity, y goes to infinity. As x goes to -infinity, y goes to -5. So I'm going to get a vertical stretch of 3, which is times y. I'm going to have a reflection over the y. I'm going to move 2 to the left and down 6. So my asymptote is going to move down 6. So if I start at 0, 1, a vertical stretch of 3 goes to 3. I can't reflect it over the y. I'm going to go 2 and then down 6. 1, 2, 3, 4, 5, 6. So my next point is 1, 2. So a vertical stretch would be 2 times 3, which is 6. I'm going to reflect it over the y, so that'll jump over here. Then I'm going to move 2 and down 6. So that gives me a domain of negative infinity to infinity, a range of negative 6 to infinity. I don't have an exact y-intercept. My asymptote is y equals negative 6. This is decreasing. As x goes to infinity, y goes to negative 6. And as x goes to negative infinity, y goes to infinity. Did you just stay home yesterday? You weren't. You're never sick. No. So on this page, this is the opposite of the exponential. These are the logs. So we're going to have to use the inverse points. So the inverse so I'm going to get 4 to the left and 2 down. So instead of 0, 1, I'm going to start at 1, 0. And I'm going to go 4, 1, 2, 3, 4, and down 2. And instead of 1, 3, I'm going to start at 3, 1. I'm going to go this way and down 2. And my asymptote, which is up and down, would get shifted 4. So the domain is going to be negative 4 to infinity. The range is negative infinity to infinity. So this is going to be increasing, and it's negative 4 to infinity. So as x goes to infinity, y is going to infinity. And as x goes to negative infinity, it doesn't go to negative infinity. So the last one is the ln, which means so I'm going to have a vertical stretch of 7/4. I'm going to have a reflection over the y. And then 3 down. So instead of 0, 1, I'm going to start at 1, 0. So if it's 1, 0, 1, 0 times 7/4 is still 0. I'm going to reflect over the y-axis and move down 3. None of these will move my asymptote, so my asymptote stays here. And my last point is 1 and 2.7. So if I reflect it over the y, and then I have a vertical stretch of 7/4. So that's times my y. So I would take the 2.7 times 7/4, which gives me so it gives me a little bit over 4. So I'm going to move it so on the second point I'm going to start again. I'm going to do 1 and 2.7, but that should be the 2.7 and 1, which would go here. Okay? And so the vertical stretch, since I'm at 1, if I multiply times 7/4, that takes me here. If I reflect it over the y and then move it down 3, I end up right here. So that gives me a domain of negative infinity to 0, a range of negative infinity to infinity. The asymptote is at x equals 0. There's none on the increasing. The whole thing is decreasing. As x goes to infinity, well, x doesn't go to infinity. As x goes to negative infinity, it goes to positive infinity.